Assalamu alaikum, dear students. Hope all of you are fine and your results are coming today. Good luck for the results. This lecture is the continuation of lectures of chapter number 1 of AS Physics. And the topic we have today is scalars and vectors. As far as our physical quantities are concerned, we have discuss the classification of physical quantities as base quantities and derived quantities as far as their simplification is concerned, or whether they are derived or they are the simplified you can say quantities. On the other hand, here we have another classification, another division of your physical quantities, and this classification based on whether physical quantities has or required a direction as well as of course magnitude and unit to specify or to understand it completely. So this is something which we have to discuss today, and scalars and vectors, as I said, is the topic today. So simply we can write here that the physical quantities are divided into two categories according to the requirement of direction for their complete understanding. Yani there are few quantities, physical quantities, for which we need not to describe any direction, and simply these quantities are termed as scalar quantities or scalars. So simply how we can define scalars? So you can write the simple definition: the physical quantities which can be specified completely only by their magnitude and units. Then there are a number of examples we can discuss here, like examples of scalars or scalar quantities. As I said, that there are number of examples we can discuss. Like in the basic discussion, we have, or you can say, the base quantities. Mass is a base quantity and is a scalar as well. Similarly, time is a base quantity and a scalar as well. But it is not always necessary that only the base quantities will be scalar quantities. Like suppose here you have a quantity which is, say, energy. So energy is not a base quantity but is a scalar quantity. Similarly, speed, temperature, and other quantities like pressure, density. All these quantities are scalar quantities, as I said, number of possibilities. Now here we have to remember one point, or we can mention that point to remember is very simple. And what is the point to remember here? So we can say that in case of scalar quantities, we can use, I'm writing here in this way, scalars can be added, subtracted, divided, and multiplied by using simple algebra or simple mathematics, you can say. What does this mean, simple mathematics? So here we can say that, like suppose you are talking about say the mass. So you can simply say that if you have a bag in which you have 5 kg of sugar and say another 10 kg of sugar, so simply you can say that we have 15 kg of sugar. So you need not to mention any direction in this case. Similarly, if you will talk about time, if someone asks you what is the time and you will say that it is 5 o'clock, so you need not to mention that it is 5 o'clock in the east, or like suppose here we have the value of 5 p.m. So 5 p.m. is just telling everything about time, and it's a 5 o'clock in the evening. So this is nothing which is you can say required direction to specify. So simply you need a value and of course a unit. You need a value and a unit, and that's it. Actually PM is not a unit, basically it's 5 hours which is the unit, but when we are talking about 5 p.m. it means that we are just telling that it is 5 is the time, but whether it's morning or evening, so PM means of course evening. So simply you can say that we need not to mention any direction in this case. So this is very important. Similarly, like suppose if you are talking about the temperature or distance or speed, all of them, like suppose if you will consider distance, so you can say that here we have say 5 meter, a person is moving 5 meter in one direction, then another direction, and there is no particular direction, but simple you can say that total length covered, like 5 meter here, say 7 meter here, 5 meter here, so this is the total length covered. So what is the distance covered? So simply you can say total length covered is the simple addition, which is 5 into 7, 12 plus 5, 17 meter. So this will be the total distance or total length covered. So distance is nothing but length covered. So total length covered. And you need not to specify any particular direction. Of course, the person is moving, but of course if it's moving in a particular direction, but you need not to mention in this case that what is the direction. So simply you can say that distance is something which is specified without mentioning any unit in this case. So these are few examples here. On the other hand, if you will go for vectors, then you can say that vectors are, we are defining here vectors. So what are vectors? So simply you can say that vectors are basically the physical quantities which need to mention a direction to understand, or we can say that the physical quantities which can be specified completely by their direction as well as their magnitudes. So this is very important, that we should know that vectors we cannot understand if we are not, we can say, using the direction, or if the information of direction is not here, so we cannot understand it completely. Like suppose if you will go for the examples, again there are a number of examples of vectors quantities as well, like the distance here, in this case the displacement, as we have been discussing displacement in your IGCSE or O level. So displacement is the shortest distance in a specified direction. So displacement is, as I said, one of the example of vectors. Similarly, when you will go for the velocity instead of the speed, you know that you have to mention the direction of the moving body. Similarly, if you want to know, or if you want to discuss the force, then force you cannot specify without mentioning that in which direction your force is. So again, as I said, there are a number of examples, like suppose you have weight, you know that weight is the force of attraction of the earth towards the center of the earth. It means that when you will talk about the, you can say, weight, basically your concern will be that you are talking about a quantity which has a particular direction. So this is something which is very important. Similarly, you have other quantities which you will discuss in your AS course, and actually few of them you have already discussed in your IGCSE or O level, like momentum. Torque is a term which you have not used in your IGCSE, but now you will use this term. And as I said, there are a number of other examples. So this is something which is important to understand, that whenever you are going to discuss the vector, or you want to define the vector, you have to mention the direction with the magnitude and the unit of the quantity. So this is what we have. On the other hand, if you can say, take another example in detail, like suppose, as I have just mentioned, that force is a vector quantity. So if you will talk about a force, suppose you have a body and here is the force of say 5 Newton. You already know that Newton is the unit of the force, and there is another force which is acting in the same direction. So you can say that direction is important, and in this case total force will be equal to 5 Newton plus 5 Newton. It means that here we are you can say adding them simply, but this will not be that simple if instead of this situation you will have a situation like this, that one force is in this direction but the other force in the opposite direction, and both of them are of 5 Newton. So in this case force, the total force or net force will not be 10, and here you have to consider the direction of forces. So if one force you are taking as positive, the other force will be negative, and when you will add them you will get 0 force, that is 0 Newton. So this is very, very important, not only in this direction, but you may have a situation where you have one force, suppose on a body in this direction, and there is another force which is in this direction. So in this case you can say that the things will not be that simple, and we have to use certain, you can say, specific methods. And here we cannot use this simple algebra, as we can use the simple algebra to calculate, or you can find out the summation or addition or subtraction or whatever in case of scalars. But in this case, of course, you cannot add them, subtract them so easily. So here you have to mention, or here you have to remember one thing which I am writing here as point to remember. So what is the point to remember? So simply you can say that point to remember is that we cannot use simple mathematics, or we can write in this way, that for vectors can not be added, subtracted, divided, or multiplied by simple mathematics, but we have to use special methods of vector algebra. We will discuss inshallah in detail what is the vector algebra, as I have given you example of force. So we can take another example, like if you have here a situation like you have a sort of ground, a rectangular ground, and a person moves from A to B, B to C. So if the value of this distance from A to B is say 5 meter, and from B to C the distance say is 10 meter, then distance is simple. Any distance you can find out simply, and this will be 5 meter plus 10 meter, as we discussed in the last you can say discussion of scalars. So 15 meter is simple distance. But as far as your displacement is concerned, so you know that displacement is the shortest distance between 2 points. So shortest distance from A to C is not AB and BC, but shortest distance is simply AC. So you can say that here we have the displacement which needs the special treatments. So displacement is simply the diagonal of this rectangle, and of course, as I said, that we need special treatment for this particular quantity. So remember one thing, that whenever you have to find out the displacement, you need a specific direction, but when you need to calculate or to find out the value of the distance, you can simply find out the distance by using the simple arithmetics. So this is something which is very important. Here we have to consider one thing, and as we have just discussed, that we need some special methods. So first of all, what we have to do here and what we can do here is the, you can say, representation of vector. So how we can represent this vector or vectors, this is very important. And to represent this vector, we need certain rules, you can say, and certain presentations. And here is the, you can say, the next heading, representation of a vector, or representation of vectors. So here this is important, that how you can find out the value. So first thing is that how you can represent this vector. So this is something which is very important. Now what we can do is, or what we have to understand, these are few points which we have to remember. And like suppose first point is that vectors are represented by an arrow. So this is the first thing. The second thing, the length or body of the arrow will give the magnitude of the vector. On the other hand, the head of the arrow will give the direction of the vector quantity. Yani, if we want to represent force, suppose, then what we have to do? We have to consider a vector. Like suppose here we have a vector, and the body of the vector will represent the magnitude of the force. But you know that as far as the force is concerned, 5 Newton, so you cannot have any possibility to draw a line of 5 Newton. So what you need something which is giving you an idea that how we can represent the 5 Newton. So to get this, what we will do, we have to select a suitable scale to draw a vector. Yani to draw an arrow, we need a scale, and we will draw the vector according to that scale. Yani suppose you have considered a force, as I said initially, force of 5 Newton, force of 5 Newton along x-axis. Suppose this is the situation. So what you have to do, first of all, you need to draw a vector, an arrow, the body of which will be the magnitude of the force, and what is the first required thing is to choose a suitable scale. So what we are doing here, we are choosing a scale, like suppose we said that 1 centimeter is equal to 1 Newton. It means that what you have to do, you have to draw a 5 centimeter line, and this 5 centimeter, as I said, is giving you the idea that basically this 5 centimeter is nothing but 5 Newton. So this is important. On the other hand, as you want to show that the direction of the force is along x-axis or in the direction of x-axis, so what actually you already know, but just to you can say remind you that as far as the x-axis and y-axis are concerned, you can mention here that these are the lines according to which you will draw your vectors. So direction indicator is another thing. So according to this direction indicator, like here you have x-axis, here you have negative x-axis and y-axis and negative y-axis. So if you want to mention the direction, then the fifth thing which is required will be the direction indicator. So we have to mention the direction indicator. Direction indicator may be your coordinates, like Cartesian coordinate like x-axis, y-axis, or you can have a situation like north, south, west, east. So this is also another way to represent the direction. So this is what is possible. But for the time being, as in our example, we are considering 5 Newton force along x-axis. So what we have to do, first thing is a suitable scale, and the second thing is also your x-axis or y-axis. So you just want to mention that along this line we have the situation of x-axis. So when you will draw the arrowhead, you have to remember that this is the direction of your vector. So this will be a complete vector. So this is something which is about the representation. But again, here we have another thing. You can say and see that this is the starting point. So we can say that this is our, say, O, and this is our terminal point, which is A. So OA is a vector. In this case, OA is a vector of 5 Newton. So what you can say, OA is a vector. So to represent this vector, what you have to do, you will write OA and you will draw a small arrow over this OA, which will show you that you are talking about the vector. O is the tail of the vector and A is the head of the vector. So this is something which is very important. Yani, one point is the representation we have of the vector quantity, how we are representing by simply an arrow. The body of the arrow is giving us the magnitude and head of the arrow is giving us the direction. Terminal point is A and initial point or starting point is O. So what we are doing, we are writing this way, that OA. Now this is the complete vector. But remember one thing, that this will not happen that if suppose the direction is somewhere here and suppose the vector is along y-axis, so you will not use the representation in this way, that OB like this. No, this is wrong. So what you have to do, again you will write OB, and again you will write in this way. And of course, this is simply the representation of the vector. This simple representation can be changed in this way, that we are writing a bold letter, like suppose here we are writing the vector P. So this is another way to write the vector. Here suppose we are writing this vector Q. So this is another way to write the vector. So bold letters you can also use to represent vectors. Another very important thing is that the magnitude of the vector, suppose OA will be given as, how you can represent OA mod. So this modulus is giving you the we can say representation for the magnitude. So this is very important. And the modulus of a vector also called its absolute value. So what we can say, how we are writing, this is something, this is modulus of OA, and this modulus is nothing but the absolute value of the vector. So you can write this point as well, the modulus of a vector, also called its absolute value. And as I said, that you can mention in this way that OA vector, and you are using this bracket sign. So this is for the magnitude, and this is for your representation of the magnitude, and the modulus is this sign. So this is what we have. And as I said initially, that O is the tail, and you have A as the head of the vector. So this is what you have. This is your, you can write even here that the initial point O of a vector is called, or is the tail of the arrow. This is the starting point, and the terminal point of the vector is the head of the arrow in, of course, in the direction of the vector. So this is very important to remember, that we are talking about a vector, and these are few things which we have to remember, that how we can represent a vector, how we can represent the magnitude of the vector, and so on. So this is something which is very important. And of course, the, as I said, that direction indicator and your x-axis or y-axis, both of these things are, you can say, important to remember and important to specify. Here, to like suppose here we have two possibilities again, and you want to suppose you want to represent your vector geographically, so what will happen? And if you want to draw it graphically, then what will happen? As far as the geometry is concerned, you know that your north, south, east, west, this will be the situation, and here you can write these points if you want. We can mention here that geographically, not geometrically, geographically, the direction of a vector is indicated by the angle which it makes with specified direction with a specified direction like as we had just discussed. What is specified direction? Any east, west, south, north, or north, south. These are the directions. So you will mention that in which direction you are. And here, of course, conventionally, you know that we have already drawn this, that conventionally we have this situation, that north, south, west, east. This is the conventional direction. So if you have a vector, like suppose you have this situation, this is your north, south, west, east, and suppose you have a vector somewhere here, then basically you can say that this vector is, of course, have a particular magnitude and has a particular direction as well. So a displacement, suppose you have a displacement of say 40 kilometer, whatever the value, 40 kilometer, 30 degree north of west. So 30 degree north of west, you have this situation here, and this vector of course has 40 kilometer. So not only this direction, as I mentioned earlier, that 40 kilometer you cannot draw on your paper. So you have to make a scale, and suppose you are saying that say 10 kilometer is equal to 1 centimeter, or 1 centimeter is equal to 10 kilometer. So you can say that 40 kilometer is equal to 4 centimeter. I didn't draw this you can say a vector to scale, but what we have, suppose this vector is OP. So simply you can say that this is the scale here, yani we will draw a 4 centimeter arrow, and this 4 centimeter arrow will be in the direction of northwest. So not only the magnitude we have to mention, but we have to mention the you can say direction as well. So this is something which is geographically you can draw. On the other hand, we can mention that what is the possibility if we want to do the same thing graphically. So what we can say, graphically, if you want to draw, then graphically the direction of a vector is indicated by an angle which it makes with a reference direction or simply you can say axis, any x-axis or y-axis or whatever, measured anti-clockwise. So remember this thing, that if you want to draw the vector graphically, then something like this you will have. Like suppose you have a situation of a displacement you have of, again suppose 40 kilometer, 150 degree, which implies that the angle 150 degree with positive x-axis, of course, as I said, counterclockwise or anti-clockwise. So this time what you can draw here, again you have the same situation, same lines, but this time you are using x-axis and y-axis or Cartesian coordinate, simply x dash, y dash. So where is your vector? So simply you can say that we have vector here in this direction, suppose. Of course this vector is, again suppose OP, and of course it will start from the origin 4 centimeter, as we have already taken the scale, but this time the angle we have to mention will be in this way, the counterclockwise 150 degree. So this is very important to show the vectors in this way. So this is something which is about the representation of vector. Inshallah, in the next discussion we will go for the other you can say or remaining part of the vector discussion. But I hope that you have understood this discussion. Quickly we can revise these things, and this is your page 1, this is your page 2, and here we have page 3. So if we will revise it quickly, so we can say that first of all the physical quantities we are talking about and the categories of the physical quantities according to their directions are scalars and vector quantities. What are scalars? So simply you can say the physical quantities which can be specified only by their magnitude and units. Yani we need not to mention any direction to understand this quantity or these quantities. Examples which we have taken as mass, time, energy, speed, temperature, and so on. And the basic point is that we need not to mention any direction in this case. And point to remember was that we can simply use the mathematics or simple mathematics we can use to add or subtract or divide or multiply these you can say quantities. I have given you example of mass. So if you have two masses of 5 kg and 10 kg, so if someone is asking that what is the total mass, so you need not to mention or you need not to know the direction, and simply you can say that it is 15 kg. Similarly, we have discussed the time 5 p.m. or 5 hour. It means that you are very much clear that what is the time, and what if someone is telling you that 5 p.m. so it's very clear. And even if someone will ask you that come after 2 hours, so you know that you have to add 2 hours simply, and you will come at 7 p.m. So you need not to you can say do anything special. Simply you are going to add these you can say values 5 plus 2 and you will get 7 pm. Similarly, if you will talk about the distance, which is another quantity, which is the scalar quantity, and you know that distance is nothing but the total length covered. So simply you need not to mention any direction, and you can say that 5 meters, 7 meters and 5 meter total distance is 17 meter. So this is something which is very important to understand, that here in these examples we need not to mention anything. Like suppose even mass, so you know that mass is the quantity of matter, so you need not to mention anything else. You know that 15 kg means the value is 15 and the unit is telling you that you are talking about the mass of a body. But on the other hand, when you will come to vectors, you have to first of all define that what are vectors. So simply you can say that physical quantities which need to mention a direction to understand, or the physical quantities which can be specified completely by their direction as well as their magnitudes and of course units. So this is very important, that in this case, in case of vectors, we need to mention not only the you can say magnitude and units, but the direction is also very important. In this case, we have discussed displacements, velocity, force, weight, momentum and torques. These are few examples of the vector quantities, and here as I said that vectors need direction. So here we suppose have an example of the force, and we discussed this point that if the force 1 say is 5 and the force F2 is also 5, so simply what we can do, we can add them when they are in the same direction. But when they are in opposite direction, as we have mentioned in this case, and when they are in the opposite direction, we cannot add them. In this case, they will cancel out the effect of each other, so ultimately the result will be 0. And similarly, I have given you another situation where these forces are making an angle theta, and of course the resultant value will be different from simple value or simple addition of 10, and for you can say this particular purpose we need special techniques. Inshallah, we will discuss those techniques as well when we will go to add or subtract these vectors. Here again, as I have already mentioned, just to quickly revise, that vectors can be added, subtracted, divided or multiplied by simple mathematics, but we have to use specific or special methods of vector quantities. We cannot add in this case or subtract, but we need special methods of vector addition or vector algebra. Here we have discussed this example, that if you have a person which is moving from point A to B and B to C, so total distance is simply A to B, B to C, length covered, yani 5 plus 10, 15. But when you will go for the displacement, this will be the diagonal of the rectangle, and you have to know this diagonal by simple measurement according to a particular scale, or you need some special methods. So this is something which is about the displacement and about the addition or subtraction of vector quantities. Here then we want to represent vector, and presentation or representation of vector is very important, because we cannot add them or subtract them or even multiply and divide. So we need some special methods, and for those we can say we need first of all to represent a vector in a particular way. So the point one is the vectors are represented by an arrow. Like suppose here you have an arrow, and this is the representation of the vector. Then I mentioned here that the length or body of the arrow will give the magnitude of the vector. So this is very important, that the length of this vector or the value of this vector will be the length of this line or body length of this line. Then another thing is that as you want to mention the direction as well, so you will use the arrowhead to represent the direction. Then of course, if you want to draw a vector on a paper, then you have to select a particular or suitable scale as well, because if you want to mention that you have a force of 5 Newton. So 5 Newton is not the you can say quantity, or Newton is not the unit which you can draw on the paper. So what we can do is simply, first of all, we have to mention, or we have to choose a suitable scale. In this example, I have taken this scale as 1 centimeter equal to 1 Newton. So as you have 5 Newton, so simply you can say that 5 centimeter is equal to 5 Newton. It means that first of all you will draw a line of 5 centimeter. Then as you have to mention the direction as well, so you have to use the direction indicator. I have written here direction. This is direction indicator basically. Direction indicator. What is direction indicator? Direction indicators are possibly your north, south, east, west, or your Cartesian coordinate x, y, z. So these are two possibilities. So here another point is that if you want to mention, or if you want to represent a vector, then how you can represent? By an arrow. And if you will write OA and you will use a small arrow over the OA, then this will give you the vector OA. And you can also represent this vector OA by a bold letter like P or like Q. I have given you here one point, and the point is that if suppose the vector is in this direction, then you will not use this way, that OB here doesn't make any sense. So remember this thing, that this is wrong. Only we have to write OB and vector OB with overhead a small arrow over OB, where O is the initial point and arrowhead is the terminal point. So all these things we have to consider here, and the rest we have discussed, and I think you have understood graphically and geographically. Of course, you know that geographically, if you want to show anything, this is the north, south, east, west thing. And graphically, if you want to you can say represent the vector, then this will give you another option, and this will be the coordinates, Cartesian coordinates x, y, z, and I have given you these examples. So I hope you have understood these initial points of vectors. Inshallah, in the next discussion we will complete the vectors and scalar discussion, and I hope you have the good understanding. Even if you are not you can say understanding any point, then you can comment in your you can say comments. You can mention that what is the problem and where you are not feeling good. So give your comments, and of course, if you are new on my channel, subscribe and like this channel and press the icon of your bell, so more students can you can say get benefit of these lectures. And as I said earlier, that if you will follow these lectures, so inshallah you will complete your course very easily. So this is what we have as far as today's discussion is concerned. And as I said, that this is your AS Physics chapter 1 continuation, and this is lecture I think 6 or 7, I didn't remember exactly, but whatever the lecture number doesn't make any difference. The topic is scalars and vectors. So good luck for your result again, and I wish you best for your future. Till the next lecture, Allah Hafiz, take care.